this session, we're going to discuss computing the deformation equation for a beam like this, a cantilever beam with a point load, a distance b away from the support, where the total length of the beam is L. The first thing is to draw the moment diagram, right? Because we're going to use the second order differential equation, and so we need the moment equation. And for this beam, the moment equation will look like this, right? P times B, right? And then 0 from there on. You can verify it yourself, just make a cut right here and compute the moment equation, which will be this: m as a function of x equals to minus pb plus p times x. If you make the cut right here, you find that there is a moment here, P times B, and there is a force equal to P, and the distance to the cut is X. So the shear and the moment, you do sum of moments here, you find P times X minus PB, which is this. Very well. So now we plug this equation here and we take one integral and we get dy dx equals to integral of minus pb plus p times x, right? Which is just integrating this equation here. Take care of one of the derivatives, and that gives us minus pbx plus px squared over 2, all of that divided by ei plus an integration constant. Now that integration constant means the angle, right? This is the slope angle at x equals to 0, right? Because when x is 0, this whole thing cancels, and then you're left with the slope at 0 is c1. Well, we know from the boundary condition that the slope at x equals to 0 is 0, which means that c1 is 0. We integrate this equation again, we get pb x squared over 2 plus px cubed divided by 3 over ei plus another constant. Similarly, evaluating this at x equals to 0, we get y at x equals to 0 is c2. And we know from the boundary condition that y at x equals to 0 is 0. So c2 is also 0. So this right here becomes the equation for the deflected shape. Now this equation is only valid in the range where this equation is valid, which is from x between 0 and b. Right? So that's that equation right there. This will be y equals to 1 over ei times minus p bx squared divided by 2 plus px cubed divided by 3. So from here to here, this is what we have. Now that equation is not valid in this range, but we can find it. We know that in this range, the moment is 0. And so when we do dy, the dy dx, we basically get dy dx is a constant. Now what's the meaning of that constant? That constant is the slope at x equals to b, right? So we can easily get that by evaluating this equation right here for the slope at x equals to b. And so the slope at x equals to b equals minus pb squared, because pb times b, plus pb squared over 2 divided by ei. So the slope at x equals to b is equal to minus pb squared divided by 2 ei, and that is C3. Because of continuity, right? The slope at this point is the same at the end of that as at the beginning of the second segment. So then the y will be the integral of that, which will be pb squared divided by 2 ei times x plus c4. So again, what is C4? Well, C4 is the value that makes this y equal to that y at b. So this deflection here at the end of this segment has to be the same as the deflection at the beginning of this segment. And so y at x equals to b, if you do the math, you get minus pb cubed over 2 plus pb cubed over 3. So you get minus pb cubed over 3ei. I'm sorry, there is a mistake here. This is a 6. Right, because cubed 3 times 2, 6. So if you plug in x equals to b, you get p minus pb cubed over 2 plus pb cubed over 6. The answer comes out to pb cubed over 3ei, and that's that deflection right there. So when we plug in here b, y has to be pb cubed over 3ei, and that's how we find b4. We get minus pb cubed over 3ei equals to minus pb squared over 2ei times b plus c4, which means that c4 equals minus pb cubed over 3 plus pb cubed over 2. So that's 1/2 minus 1/3. 3 minus 2, 1/6. So it's pb cubed over 6ei. And And with that, that goes in there, and we get the equation of y. So in this segment, y is equal to 1 over EI times, again, this is a 6 right here, 1 over EI minus PB squared over 2EI plus PB cubed over, there's no EI here, over x divided by 6, right? That's the equation for this branch. That's the equation for this branch of the deflected shape. Okay?